So we had started with CPU architecture, third lesson yesterday. We had seen that the CPU is generally used for executing all the instructions which are given as an input by the user. It also includes various components like registers, ALU, and control unit. In the ALU, we had seen what are the different components that a ALU has. Along with that, CPU also performs various operations like shift operations, which is a part of your ALU. So your ALU has status registers. It has a shifter, which is used for performing the right shift and the left shift operation. It has complementer, which is used to perform ones and twos complement. And it has arithmetic and Boolean logic, which actually performs your arithmetic and logical operations like addition, subtraction, multiplication, division, logical and logical or, etc. Then register is a part which is used for storing some data. So for every CPU, we have different register and the function of those registers differ from one to another. And the last is a control unit, which is used for controlling your ALU as well as the register. So, and the bus that is used for the bus that connects your register and the ALU is your internal CPU bus, and your control flags and control signals controls your ALU and the register with the help of control unit. So we had seen the diagram of our internal structure of the CPU. Then, as I said, that there are multiple processors that are there inside the computer system. Like initially we had 8085, then we had 8086, 80286, 386, 486, and then nowadays we have i3, i5, i6, i7, and so on. So every processor is different from one to another depending upon certain configuration, like the data bus size will be different, address bus size will be different, the chip or ALU chip size will be different, instruction queues will be different. So all this keeps on changing from one processor to another processor. So we had started studying about 80386 processor. What does the architecture of 386 says? That it has three different units. Which are those three different units? BIU stands for bus interface unit, CPU stands for central processing unit, and MMU stands for memory management unit. As the name says, bus interface unit, what will this look after? It will look after all the buses which are there inside the 80386 processor. Who will do all the brain work, addition, subtraction, multiplication, division, logical and logical or shift, right shift, left shift, rotate, and all will be done by the CPU. And who is going to manage the memory part is a MMU, memory management unit. So we had seen that in the bus interface unit of 80386, we have 32-bit of address bus and 32-bit of data bus. So I can transmit 32-bit of a data at a single time. Why? Because that much is the size of my bus. I can also transmit individual 8 bits, individual 16 bits also. But if I want to transmit a 64-bit of a data, what I have to do is I have to use my data bus 2 times. First time to transmit first 32-bit of a data, and next time to transmit next 32-bit of a data. So it is not necessary कि अगर मेरा bus size 32-bit का है तो I cannot transmit 64 or 128-bit of data. I can do that, but I have to use a data bus for multiple times. Then we had seen that it has an instruction unit, instruction queue of 16 bytes. What does that instruction queue store? It stores all the instructions which are there inside the program given by the user for execution. So if I have written a program for addition of a 2 number, so वो program में I will have many instructions. Where are those individual instructions stored? They are stored inside the instruction queue. How they will be executed? They will be executed one after another. Why? Because it is a queue. So पहले एक execute होगा, उसके बाद ही दूसरा execute होगा. So what is the size of that queue? It is of 16 bytes. That means up till 16 bytes I can store the instruction. But whenever one instruction is executed, it automatically creates a space for another instruction to get loaded. So never your instruction queue never sits idle. It is always loaded with the instruction. But are the instructions getting executed in the instruction queue? No, your instructions are not executed. They are just stored there. They will be taken by the CPU and then they will be executed. Okay. So it also has a concept of address pipelining, which means what? Multiple instructions can be executed at the same time, but this is assumed by the user, but it is not actually happening. Whenever any instruction has gone for the memory, at that time CPU takes the next instruction for execution, and therefore it is assumed to the user that multiple instructions are executed. Okay. Then we had seen CPU. What does your CPU contains? It has two units, your IU, that is instruction unit, and EU, that is execution unit. Where is your ALU? ALU is inside your EU. What is the function of instruction unit? The instruction queue of your BIU is connected to your instruction unit. So the instructions which are there inside the instruction queue are taken one by one for the execution by your instruction unit, which is there inside the CPU. After those instructions are executed, where they are stored inside the memory. So which is the memory of your 80386? It is either the paging type of memory or segmentation type of memory. So if it is a paging type, what does it has? Your memory is divided into different pages, and each of the page has a page number. So page number is nothing but the address, and then I go to that particular page number and store the data or retrieve the data. Similarly, if it is segment, your memory is divided into different segment, and each and every segment has a segment number. So your segment number is nothing but the address. So I go to the segment number and store my data. And if I want to retrieve that data, I will make use of again the store segment number. Okay. So this was your architecture of the 80386. Now we saw that the CPU has registers. So your 80386 also has register. How many register it has? It has two types of registers. One is a user visible register and the other is control and status register. So which of them are user visible register? General purpose register GPR, DR data register, AR address register, and CCR, that is condition code register. So these are the user visible register. Apart from that, we have control and status register also. Which are they? PC program counter, IR instruction register, MAR memory address register, and MDR memory data register. Now we'll be looking at these registers in detail today.
Ma'am.
Yes.
Ma'am, in the components of the CPU means 80386, it was written BUI. Then how does it stand for bus interface unit?
Yes, it is bus interface unit. By mistakenly, I have written BUI. This is bus interface unit only. By mistake, it has been typed as BUI. Okay. So today we'll be starting with the first register, that is GPR. What is GPR? It is a general purpose register. Now, what do you mean by general purpose register? It is used for holding the operands of instruction. It is used for holding the operand of instruction means what? I have an instruction, for example, move A, B. So ये move MOV क्या है? It is a operand, and A, B is what? Opcode. Now, what do you mean by opcode? The place or the variable where my data is there, inside which my data is there, it is considered to be as opcode. But the instruction MOV is considered to be as operand. If I give you an instruction add A, B, what is add? Add is a operand. If I give you an instruction SUB, subtract A, B, what is your SUB? It is nothing but a operand. If I give you an instruction MUL, that is multiplication A, B, what is that MUL? It is operand. तो ये जो instructions है उसके operand, where are they stored? They are stored inside the GPR. So the general purpose register is used for what? It is used to hold all the operands which are there inside your program. तो अगर आपके प्रोग्राम में you have MOV, you have ADD, add, SUB, subtract, MUL, multiplication, DIV, division, then LOAD, load, then STA, store. So all these instructions will be, or all these operands will be stored where? They will be stored inside the general purpose register. Okay. Is GPR clear?
Yes, sir.
Okay. Now the second type of register or a second type of user visible register is DR. What does DR stands for? Data register. So as a name says, data register, what it will hold? It will hold the data. So what was my instruction? Move A, B. तो मैंने MOV move store कर दिया GPR में. But have I stored the value of A and B anywhere? No. Where the value of A is equal to 3 and B is equal to 3 will be stored. It will be stored inside the data register. Okay. So in short, your operands are stored in GPR and your opcode, which is nothing but the data, is stored where? Inside the data register. Is the difference between both clear? So if I have an instruction add A, B, your ADD add is stored in GPR and the value of A, which is 1, and the value of B, which is say suppose 2. This 1 and 2 value of A and B variables are stored where? They are stored inside the data register. Clear? Then next, I have AR, which is called as address register. Why are they used for? They are used for the purpose of addressing. What did I say? Move A comma B is an instruction. मैंने MOV स्टोर कर दिया है GPR में, that is general purpose register में. Value of A and B I have stored it into DR, that is data register. But where is this? What is this entire instruction at the address stored? ये पूरा instruction कोई तो address पे stored है. Where is that address, or who is going to give me that address? It will be given by the address register. मतलब पूरा इंस्ट्रक्शन किधर स्टोर होगा? इट विल बी स्टोर्ड ऑन सम एड्रेस. एंड वेयर विल आई टेक द एड्रेस फ्रॉम? आई विल टेक द एड्रेस फ्रॉम द एड्रेस रजिस्टर. इज दिस अंडरस्टूड? So address register will give me the address where that particular instruction is stored. Once I got that instruction MOV A comma B, I will store MOV into GPR and I will store A comma B into DR. Is this clear? Yes.
Yes, ma'am.
Okay. So in AR, that is inside address register, I have something called as SP, and before that let me show you this. Okay. In the address register, I have something called as SR, IR and SP. That is segment register, index register and stack pointer. What are all these three? They are, all these three are the part of your address register. Okay. Segment, index and stack. Now let us come here. So SP, that is, it should not be SP, it should be SR. Okay. Segment register holds the base of the segment. Index register is used for indexing. And stack pointer SP points to the top of the stack, which performs push and pop operation. Now, what is this? Let us go from down. What is the stack pointer? Now, stack means what? It is a place where the data is stored. So how is the data stored inside the stack? Suppose if I have too many books, how will I, and if I ask you to keep the books one upon another, so how will you keep? Your first book is, say, suppose of maths. So you'll keep maths. Then I ask you to keep a book of C++. Where you will keep a book upon it, because I have told you keep ek ke upar ek. So first I will keep a book of maths. Then I will keep a book of C++. Then I have asked you to keep the book of digital. So you have kept the book of digital. Again on C++. Then I have asked you to keep a book of CO. You will keep the book of CO upon DE. Okay. Now if I ask you to remove the books, how will you remove? In your computer system, you have to remove the book which you have kept last. Which is the one which you have kept last? It was CO. So you remove CO. Then you will remove DE. Then you will remove C++, and then you will remove maths. So what was happening? The book which went first inside was the last to come out. Are you understanding me? The book which was first gone inside, which is maths, was the last to come out. So this stack pointer, how does it operate? It operates in the same manner. The data which was inserted first will be the last to come out. So it operates in the manner called as first in, last out. FILO. First in, last out. The data which went first inside will be the last to come out. Okay. So how do I put the instructions, or how do I put the data inside? By using this push command. So जैसे MOV command है, वैसे PUSH क्या है? Push. ठीक है. So push means to insert the data inside, and pop means to take the data outside. So I will push maths book first, then I will push C++ book inside, then I will push digital book inside, and then I will push CO book inside. When I want to pop, I cannot pop maths book outside. Why? Because uske upar I have digital also, C++ also, CO also. So first I will pop CO out, then I will pop digital out, then I will pop C++ out, and then I will pop maths out. Okay. So how is the stack pointer working? It is working. That means it is a place where the instructions are stored. How are the instructions stored? By using push operation. And how are the instructions removed? They are removed by using pop operation. How are they stored? The one which has gone first inside will be the last to come outside. Okay. Now, what is this SP? This was all about stack. Huh? This is how the stack operates. But what is stack pointer? Now, initially I have maths. In the stack, if I have only maths, so where is my pointer pointing? To the maths. Now, if I add C++, where will my pointer point? To C++. Why? Because I have added C++. Now, when I add digital, where will my pointer point? It will point to digital. Why? Because I just added digital. If I add CO, where will my pointer point? It will point to the CO. So did you see my pointer is increasing or it is incrementing as and when I put the data inside. Similarly, now my pointer is at CO because that was the last book that I inserted. When I remove CO, where will the pointer point? It will point again to digital. When I remove digital, it will point to C++. When I remove C++, it will point to maths. When I remove maths, it will tell me, the pointer will tell me your stack is empty. Is this understood? That is how your stack pointer works. Am I clear?
Yes, ma'am.
Okay,
Yes,
so
ma'am.
the stack is a place where your instructions are stored, and whichever instruction it has added, your stack pointer will point that particular instruction. If you are removing the instruction, whichever instruction is removed and whichever is the next in the stack, your pointer will be pointing there. Okay. Next, we have IR, that is index register. Now, what is index register? To every, have you seen the notebook? Notebook has page number and it also has an index. So if I tell you go to the topic called as say suppose C++ topic or introduction to C++ topic, will you search each and every page for that topic? No. What you will do is you will search the index. Index में जिधर लिखा है introduction to C++, you will directly go to that particular page. Yes or no? Instead of searching for the entire book for the topic, you will search only the index. So similarly, what is the index register here? You will have too many instructions in the computer. To every instruction, an index number is given, and that index number is stored in a separate memory. So when I want any instruction to be searched, I will not go and search all the instruction, but I will search for that instruction in the index. From the index, I will take the address and I will directly go to that particular address and search for the instruction. That is what is called as index register. So what is that index register maintaining? It is maintaining the list of all the index number given to each and every instruction. And why? What is the purpose of this index register? To increase the speed of searching the data. So if I have 1000 instruction and if I ask you to search for instruction move A comma B, which is at the location 900, will you search all the 900 instruction from one? No. You will just search for the index number for that particular instruction inside the index register. एक बार इंडेक्स रजिस्टर से उसका एड्रेस मिल गया तो यू विल डायरेक्टली गो टू द एड्रेस रजिस्टर एंड टेक द instruction from there. Is this index register clear to you?
Yes.
Okay, so we have done two types of address register, the index register and the stack pointer. Now the last is the segment register. Now what is segment register? It holds the base of the segment. Now what is that segment? It is a part of a memory. Yes, we have seen in the memory management unit. Okay, you have two types of memory management unit. One is segment and another is paging. अगर segment है तो how is the data stored? It is stored inside the segment, and every segment has a segment number. So where is the detail of that segment number stored? The detail of the segment number is stored inside the segment register. Okay, this is SR. By mistakenly I've written it SP. It is SR. So what is that segment register holding? It is holding the addresses of each and every segments which are there inside your memory, and in that memory you have your data stored. So is the address registers clear to you? Your address register is holding the addresses but in three different form. If the data is in the stack, it will use stack pointer. If the data has index, it will use index register. If a data has segment, it will make use of segment register. Is this clear? So we have done three registers: general purpose register, data register and address register with the types. Clear?
Yes,
Or
ma'am.
no? Okay. So now
Yes, ma'am.
let us see other register, that is condition code register. Now, what is this condition code register? Whatever ALU operations I do, addition, subtraction, multiplication, division, logical and logical or shift, complement, whatever operations I do, all the status of this operation is stored with the help of some condition codes. Which are those condition codes? You have sign bit, 0 bit, carry bit, overflow, interrupt. Okay. Now let me show you the diagram. Can you see this tab? Just a minute. Can you see this part? D0, D1, D2, D3, D4, D5, D6, D7.
Yes, sir.
See, no? Okay. So what are these? These are nothing but the condition code. Now the one which I am showing you is for 8085. Okay. Similarly, we will also be seeing it for 80386. Okay. For now, let us understand first for 8085 so that it becomes easy for us to understand for 80386. Okay. So what are these D0 to D7? These are nothing but the bits. So how many bits your status flag has? It has 8 bits. But कौन सा for 8085? Huh? 80386 का number of the bits will be different. First is CY. Can you see that CY? It is for carry. P is for parity. A is for auxiliary carry. Z is for 0. S is for sign. Okay. Now if I give you a number 33, is this number positive or negative? It is positive. So if it is positive, what will be set at the sign? Two values will be set, either 1 or 0. ठीक है? तो अगर positive है तो it will be set to 0. Negative है तो it will be set to 1. Understood? That is what is your sign bit. S flag. So D7 will be set either to 0 or 1 depending upon the number sign. If the sign of the number is positive, it will set to 0. If the sign of the number is negative, it will be set to 1. So if it is 33, what will I set over here is 0. But if it is minus 44, what will I set this to? 1. Is this S clear to you?
Yes.
So we have same sign S in our 80386 also. So it will check whether the number is positive or negative. Agar positive hai, तो it will put 0 over here. If it is positive, if it is negative, it will put 1 over here. Clear? Now next is Z. Z is for 0. Now what is 0? When I do any operation and when I get result as everything 0. Say suppose if I add 0 plus 0, what is my result? 0. So for any operation, if my result is 0, this flag will be set to 1. But if my result is not 0, this flag will be set to 0. I repeat. If the result of any operation is all zeros, the flag will be set to 1. But if the result of any operation is non-zero, then the flag will be set to 0. Is this clear?
Yes.
Ma'am, can you repeat, ma'am?
Yes, I repeat. If when you perform any operation and if the result of that operation contains all zeros, that means this flag, 0 flag, will be set to the value 1. But if whenever I perform any operation and if the result has non-zero, non-zero means 0 1 0 1 है या सारे 1 है, ऐसा है तो ये flag will be set to 0. Is this understood? Okay, so when I do 0 0 0 0 plus 0 0 0 0, what is my answer? 0 0 0 0. So is the answer containing all 0? Yes. So what will I set this to? 1. But if I have operation like 0001 plus 0000. So what is my last bit? 1 plus 0 is 1. So what will be my result? 0001. Is my result having all the zeros? No, it has 1. So what will this bit be set to? It will be set to 0. Is this now clear?
Yes, ma'am.
Okay. Next is AC. What is AC? Auxiliary carry. What does auxiliary carry means? Whenever I perform a addition of a number, and if that addition has a carry from a third bit to a fourth bit, which means if I have a number 0100, I am putting it in the chat box. Okay, see, if I have a number 0100, and if I add this number with 0100, do I have a carry at the third bit? Yes. What is the third bit? 1 plus 1 0, and a carry on a fourth bit as 1. Yes or no? Are you all understanding?
Yes.
At the third bit, I have a number 1 and 1. When I add 1 and 1, I get answer as 0, but a carry is generated on the fourth bit. So whenever I have a carry from a third bit to a fourth bit, I will be setting this auxiliary carry value as 1. But if suppose I have a number like this, is there a carry from third bit to the fourth bit? No. 0 plus 0 is 0 with no carry. So in this case, the auxiliary will be set to 0. Are you understanding?
Ma'am, what if the carry is generated at the second bit?
It will not consider. At that time, this flag will be 0 only. अगर कैरी जनरेट हुआ है थर्ड बिट से फोर्थ बिट पे, तो ही ये फ्लैग 1 सेट होगा. बाकी कोई भी बिट, फर्स्ट बोलो, सेकंड बोलो, लास्ट बोलो, 13th बिट बोलो, 16th बिट बोलो, किसी में भी कैरी जनरेट हुआ तो भी ये बिट का वैल्यू 0 ही होगा. बट इट विल बी सेट 1 ओनली व्हेन देयर इज अ कैरी फ्रॉम थर्ड टू फोर्थ बिट. क्लियर?
Yes.
Okay. Then next, can you see P written? P is for parity. Now what is parity? We have two types of parity, even and odd. Now if you remember, I had told you this. If I have all the ones, look in the chat box. If I have a value 1111, how many ones I have? 4. Is the number even? Yes, 4 is even. So my parity will be set to 1. But if I have like this, a number like this, 0111, is it a parity even? No. Why? Because 3 is odd. So my bit will be set to 0. So when I have even parity, sorry. So when I have even parity, which means number of ones are even, my parity will be set to 1. But if at all I have odd parity, that means if the number of ones are odd, my P bit will be set to 0. Is this clear to you?
Yes, sir.
But
Yes,
where you have to check this even and odd, you have to check it in the answer, not in the question. Answer जो result मिलेगा उसमें you have to count number of ones. अगर वो even निकला तो set this P bit to 1, odd निकला तो set it to 0. Okay. Now last, can you see CY carry? Now what is that carry? If entire result के last bit पे carry है, that means this flag will be set to 0. So for example, if I have a number 10, look in the chat box. If I have a number 1000 plus 1000, will my final result generate a carry? Yes. Will it generate a carry?
Yes.
Yes.
So in this case, when my final result is generating a carry, at that time this bit is set to 0. Sorry, this bit is set to 1. If it is not generating a carry at the end, it is set to 0. Clear?
Yes.
So whenever any of this value affects, at that time it is set to 1. If it is not affecting, it is set to 0. Is this clear?
Yes, sir.
Okay. So similarly, we have sign bit, which as I explained you, so 8085 and 80386 ka sign bit is same. 0 bit is also same. Carry bit is also same. Overflow and interrupt we will do when we go to the next slide. Okay. For now, remember only these three bits. Now it also has P parity in this. It also has AC auxiliary in this. Okay. So the functions of sign, zero, carry, auxiliary carry and parity, which we have just seen, are similar for 8085 also and are similar for 80386 also. But 386 has little extra. What are those extra? That we will be seeing in the next slides. Okay. Are these conditions code clear to you?
Yes, sir. Yes.
So with this, we complete with the user visible registers. GPR, which stores operand, DR, which stores opcode, that is the data. Then address register, which stores the address, but in three different form, either segment or index or stack pointer. And last, condition codes, which will tell you the status after the ALU operations are performed. What status? Status like sign, parity, carry, overflow, auxiliary carry, and zero. Clear? Is this understood?
Yes, ma'am.
Okay. Now let us start with the control and status register. So with this, we have completed user visible. Now we are starting with the control and status registers. Which are they? PC. What is PC? Program counter. What is the function of program counter? It is going to tell you which is the next instruction to be executed. So program counter points the next instruction in the queue which has to be executed. तो ये आपका जो इंस्ट्रक्शन क्यू था inside your bus interface unit, the instruction queue of your bus interface unit, who will point to the instructions, the program counter will keep on pointing to the instruction which has to be executed. Clear? What is?
Ma'am, will it point to the instruction queue or the decoded queue?
Will it point to
The instruction queue or the decoded queue?
decoded queue? इंस्ट्रक्शन क्यू से इंस्ट्रक्शन डिकोडेड में जाएंगे, डिकोडेड में पॉइंटर पॉइंट करेगा. बट व्हाई डिड आई टेल यू इंस्ट्रक्शन क्यू? बिकॉज योर इंस्ट्रक्शंस आर देयर इनसाइड द इंस्ट्रक्शन क्यू. तो एक बार इंस्ट्रक्शन क्यू से डिकोडेड में गया, उसके बाद द प्रोग्राम काउंटर विल स्टार्ट पॉइंटिंग. ओके
ओके मैम.
हाँ, जब भी एग्जीक्यूशन होगा तब भी पॉइंटिंग होगा. तो एग्जीक्यूशन आपका आईयू में होगा तो तभी इंस्ट्रक्शन पॉइंट्स होंगे. ठीक है. Next is IR. What is IR? Instruction register. What does it contain? It contains recently fetched instruction. So whenever the instructions are fetched from instruction queue and wherever they are going to be stored in your decoded queue, who will maintain the recently fetched instructions? It will be maintained by your instruction register. I think you are aware about this because this was explained in the first chapter also. Okay. What is next? Memory address register. What is memory address register? Going to store the addresses of each and every memory of the instructions which are there inside your memory. And who will point to the data of those instructions? It will be pointed by your memory data register. So your MAR will point the address and your data will be pointed by your MDR. So is all these control and status registers clear to you?
Yes, ma'am.
Okay, so with this we complete different registers of 80386. We have GPR, we have DR, we have AR, we have CCR, PC, IR, MAR, MDR. Total 8 registers divided into 2 groups. That is user visible register, control and status register. Clear? Yes or no?
Yes, ma'am.
Okay. Now let us see next. Register organization of 80886. See, this is for 8086. Huh? Again, do not get confused. It is 8086, not 386. What is happening? We have seen kitne registers hai apne paas. We have GPR, we have DR, we have AR, we have CCR, we have PC, we have IR, we have MDR, we have MAR. We know what is the function of each and every register. But do we know what is the size of the register? No. So the size of each and every register and how they are going to operate, that we will be studying in the register organization of 8086. Okay. Why it is 8086? Because 8086 ka organization and 80386 ka organization is same. So even if it is asked in the exam, write down the register organization of 80386, it will be same. If it is asked register organization of 8086, it will be same. Is this clear to you?
Yes, ma'am. Yes.
Okay. Register organization talks about what? It talks about the size of different register that we have just studied. Okay. We know what is GPR, but we do not know what is the size of the GPR. So what is the size and how it is going to work, that we will be seeing. So what is GPR? General purpose register. क्या काम करता है general purpose register? It is used to store the operand. So if I have an instruction add a comma b, where is that add going to get stored? Inside the GPR. Where is a and b going to store? They will be getting stored in DR. So a register visible to the programmer. Why it is visible? Because it comes under which category? User visible register. So these registers can be seen by the user. Okay. Therefore, they are called as user visible register. कितने general purpose registers है? We have 4 general purpose register. They are called as AX, BX, CX, and DX. Okay. So how many general purpose registers are there? We have 4 general purpose registers, and the name of those registers are AX, BX, CX, and DX. सबका size कितना है? 16 bit. AX has 16 bit size, BX has 16 bit size, CX has 16 bit size, and DX has 16 bit size. चारों का ऑपरेशन इज अलग. AX का जो काम है वो BX नहीं करेगा, BX का जो काम है वो CX नहीं करेगा, CX का जो काम है वो DX नहीं करेगा. ठीक है. तीनों का और चारों का साइज है 16 bits. Now look at the next point. It can be accessed as 2 8-bit registers. That means I can divide this 16 into 2 8. Correct? No? 8 plus 8 is equal to 16. So I can use this entire AX as 2 8-bit registers. How? One as lower 8-bit and one as higher 8-bit. तो जो lower है उसको हम बोलेंगे AL और जो higher है उसको हम बोलेंगे AH. So in short, your AX is equal to AH plus AL, where AL is nothing but the lower 8 bits and H stands for higher 8 bits. So lower 8 bits plus higher 8 bits is equal to AX, which is of 16 bits. Is this understood to you?
Yes, ma'am.
Everybody?
Yes, ma'am.
Okay. So your AX is of 16 bits, which is divided into AH of 8 bit and AL of 8 bit. Similarly, your BX is divided into 2 8 bits, BH of 8 bits and BL of 8 bit. Similarly, CX is of 16 bits divided into 2 CH of 8 bit and CL of 8 bit. Again, DX is of 16 bits divided into DH higher 8 bits and DL lower 8 bits. Can you see that in the diagram over here? AH plus AL is equal to AX. BH, this should be H. BH plus BL is equal to 8 bits. CH plus CL is equal to 8 bits. And DH plus DL is equal to DX of 16 bits. Is this understood? Yes or no? Have I lost the connection?
No, ma'am. No.
So has everyone understood, girls?
Yes, ma'am.
Okay. So all these 4 are of 16 bits, but I can use them as lower 8 bits as well as higher 8 bits. Okay. Now why it is A? A stands for accumulator. So what is the function of accumulator? It is used for storing the results. Do you remember? AC is equal to AC plus M. So what are those? Add the content of M plus accumulator and store the result inside accumulator. So what is this A for? A is for accumulator. And what is the function of accumulator? Accumulator is used for storing the result. तो आपका ALU जो भी ऑपरेशन करेगा वो ऑपरेशन का रिजल्ट किधर स्टोर होगा? इट विल बी स्टोर्ड इन विच रजिस्टर? जीपीआर रजिस्टर. बट विच पार्ट ऑफ जीपीआर रजिस्टर? द AX register, which is accumulator. Is this understood?
Yes, sir.
Okay. Let us go to the next now. B. BX is used as base addressing for forming the physical address. Now, as we know that we have two types of memories, which are those paging and segmentation. ठीक है? तो paging में क्या है? Page number है. Correct? So if it is page number, what is going to happen? I have to, my system, that is my computer, understands the physical addresses. But the address which is generated by your paging and segmentation is logical address. So I have to convert this logical address into physical address. So which register is going to help me to make this physical address? It is nothing but the base register. ठीक है? तो base register का क्या काम है? जो भी लॉजिकल एड्रेस आपके पेजिंग कंसेप्ट ने बनाया है, वो लॉजिकल एड्रेस को फिजिकल एड्रेस में कन्वर्ट करो. ओके. Apart from that, what is the other use of BX? It is also used as data register. तो आपका जो डेटा है, वो डेटा will be stored inside which register? Inside the BX register. Okay. But majorly it is used for performing this conversion of logical address into physical address. Who generates that logical address? Your pages. And it is a duty of BX to convert into physical. Why? Because your computer will not understand logical address. It understands only physical. So the conversion of logical to physical addressing is done by this base register. Okay. So your B stands for base register. Clear? Then next we have is CX register. What is CX? It is used as counter. So C stands for counter. When it is used in loop and string instruction. तो जब भी मेरे प्रोग्राम में कुछ लूप है, तो वो लूप का काउंटिंग कौन करेगा? It will be done by your CX register. Do you use loops in your C programming? You have for loop, you have while loop. उसका काउंट कौन करता है? Counter of your CPU. So whenever I have a program in which I have some loop instructions or a string instruction, ये दोनों का count कौन रखेगा? It will be maintained by the CX register, which is the count register, and it is a part of your general purpose register. Is this clear? Then the last we have is BH and BL. What are they? It is used as an operand or destination in case of any register. Now, for example, if I have my, what is the function of GPR? I told it is used for storing the operands. But which part of your GPR is, or which register of your GPR will be storing the operand? It will be the DX. क्योंकि रिजल्ट accumulator में है, डेटाबेस में है, काउंट C में है, तो ऑपरेंड मूव किधर जाएगा? बोला तो GPR है, but which part of GPR? The DX register of your GPR. So your move A comma B, your move instruction will go into which GPR? Will go into your DX register of your GPR. Okay, is this GPR understood to you?
Yes, sir.
So it is called as user visible register because all these registers are visible to the user. How they are visible to the user? This you will be understanding more better in your 4th semester when you do microprocessor programming. ठीक है, उसमें जब ये आप असेंबली लैंग्वेज प्रोग्राम लिखोगे और रन करोगे ना, तभी जब रन करोगे तब ये सारे रजिस्टर्स की वैल्यूज आपको दिखेगी. ओके, सो देयरफॉर दे आर कॉल्ड एज यूजर विजिबल रजिस्टर. So these are the 4 different types of your GPR. Okay. Now next we will be doing is the segment register. The segment register is part of what? It is a part of your address register. Do you remember? Your segment,
Yes.
segment registers are part of your address register. So let us see which are the different types of segment registers. What are different types? We have CS, DS, ES, and SS. What is CS? Code segment. DS, data segment. ES, extra segment. SS, stack segment. Okay. Now, do you know what is stack? Yes. So where is the data of all the stack going to maintain inside the stack register? अगर segment register के अंदर मैंने stack बनाया है, तो वो सारा stack का data किधर store होगा? Inside the stack segment data. Okay, so जो भी stack का data है, all those stack data will be stored inside which segment? Inside the stack segment. Where is that stack segment? It is there inside the segment register. What details will be stored in the stack segment? That whichever data was gone inside first will be the last to come out. And if I want to put the data inside stack, I will make use of push instruction in my program. And whenever I want to remove the data or instruction from the stack, I will make use of pop command inside my program. Okay. Then I have extra segment. What is this extra segment? If all these segments are full and if I still want some space for additional data, what I make use of? I make use of this extra segment. So this extra is doing actual work of extra. अगर बाकी सब खत्म हो गया है तो वो जो भी extra है, I have to put it in the extra segment. Okay. What is code segment? It is used for, it is used for addressing a memory location, which means my entire program is getting stored somewhere. Code is nothing but the program. Okay. Whenever I write that program, it is called to be as a code. Alternative name is code. Either I can call it as code or I can call it as program. So what is happening? Where is that entire thing stored? Alag-alag instructions to store ho hi rahe, but entire program is stored where? It is stored at some memory location, and that memory location is stored where? It is stored inside the code segment. तो अगर मुझे पूरा प्रोग्राम देखना है सिस्टम में कि वो किधर स्टोर है, सो वेयर आई हैव टू गो, आई हैव टू फर्स्ट गो इनसाइड द कोड सेगमेंट, टेक द एड्रेस ऑफ इट and then go to that address and take the entire code. Okay, so my system is storing instructions also separately, and it is storing entire program also at one place. And which is the place where the program is stored? It is stored inside the code segment. Okay, where is the detail of this data of the segment store? It is stored inside the data segment. What does it do? It points to the data memory, which means मैंने जो कोड इधर स्टोर किया है उसके अंदर जो भी इंडिविजुअल डेटा है, where is the detail of that individual data stored? It is stored inside the data segment. Everything with related to this program, that means related to program, is stored inside code and data segment, and related to instruction also is getting stored inside my system. That means I can consider it as a type of a backup. मेरे पास इंस्ट्रक्शन का डिटेल्स भी है, आई हैव इंस्ट्रक्शंस ऑफ अ प्रोग्राम आल्सो, बट सिस्टम जनरली प्रेफर्स यूजिंग इंस्ट्रक्शन एज कंपेयर टू प्रोग्राम. अगर इंस्ट्रक्शंस को कुछ हो गया, then only it will go and touch the program, but generally nothing happens to the instruction. Instructions are easily taken in and taken out. Why system prefers instructions and not program? Because first is understanding the instruction is much easier to the system than understanding the entire program. Okay, and second thing is each and every detail of the instruction is also stored. Therefore executing the instruction, that is one single line, is much faster as compared to executing multiple lines of a program at a one time. Okay, so therefore preferring to instruction is much more by the computer as compared to preferring of the programs. So this code segment and data segments are hardly being touched by the processor. कभी टच होगा अगर मुझे कुछ इंस्ट्रक्शन मिल ही नहीं रहा है या कुछ प्रॉब्लम हो रहा है तब भी, until and unless these two will never be touched by your processor. Okay, so what is this segment register? It is divided into 4. It stores the detail of your entire program, the data of the program, data in the form of the stack, and if anything is extra, it will store all that extra thing with related to that program in the extra segment. Is this clear?
Yes, ma'am.
So you have 4 different types of segment registers: code segment, data segment, extra segment, and the stack segment. Okay, let us go to next. Now, what do you mean by flag registers? Flag registers are again the same as status register. कोई भी operation होने के बाद the details of that operations are reflected inside the flag registers. Okay, what are the flag bits set to? They are set to either 1 or 0. Okay, set means 1, reset means 0. Now out of this, I have already shown you what is carry, what is parity, what is auxiliary, what is 0, and what is sign. Let us once again see. You have 6 status flags: sign, 0, auxiliary carry, parity, and normal carry. What is sign? After any operation, if MSB, that is bit 7 of a result is 1, it indicates that a number is negative, and the sign flag becomes set, that is 1. तो अगर number negative है तो 1 होगा, positive है तो 0 होगा. So 1 is set if the number is negative, 0 is set if the number is positive. Okay, that is what is sign flag. Next is zero flag. What is zero? After any arithmetic or logic operation, if the result is zero, that means 0 0. अगर result में सब कुछ 0 है, तो क्या होगा? Zero flag set हो जाएगा. Set मतलब value हो जाएगा 1. Otherwise, it will be reset. That means it will be set to 0. तो अगर result सारा 0 है, तो 1 set होगा. अगर result non zero है, non zero means एक आधा भी 1 है, तो वो flag का value क्या हो जाएगा? 0. Where I am setting this flag values, I am setting it on the bit number D5. Do you remember 8085 को सिर्फ 8 थे, D0 से D7, but your 80386 has 16, D0 से D15. Can you see that?
Yes.
But why did I explain you 8085 first, so that you understand these bits, sign, zero, auxiliary, parity and carry. ठीक है? तो जीरो फ्लैग किधर सेट होगा? D6 पे. तो अगर मेरा रिजल्ट सारा 0 आया, तो व्हाट विल आई मेक दिस D6 बिट एज 1. बट अगर नॉन 0 आया, तो व्हाट विल आई मेक दिस D6 बिट एज 0. इज दिस अंडरस्टूड? Yes or no?
Yes. Yes.
Similarly for sign, अगर वैल्यू मेरा नंबर नेगेटिव है, तो आई विल सेट दिस बिट D7 बिट टू 1. बट अगर पॉजिटिव है, तो आई विल सेट दिस D7 बिट टू 0. Okay. Next is auxiliary carry. So if a carry is generated from D3 to D4 bit, what will happen? I will set the flag to 1. Otherwise, I will set the flag to 0. So can you see this third bit? It is 1 1. So carry generate होगा क्या? हाँ, generate होगा. तो what will I set this? I will set this bit D4 as 1. क्यों 1 set किया? Because there was a carry from third bit to fourth bit. So I will set to 1. बट अगर कैरी नहीं होता थर्ड बिट से फोर्थ बिट पे, तो आई वुड हैव सेट दिस D4 बिट एज 0. इज दिस अंडरस्टूड? Yes or no?
Yes, ma'am.
Yes, ma'am.
Come to parity now. What did I say? Even parity 1, odd parity 0. So can you see this is the result? कितने 1 है? Number of ones is 2. Is 2 even or odd? It is even. So I will set it to 1. How many ones I have over here? 3. Is it even or odd? Odd. So I will set to 0. तो अगर मेरा result में even parity है, so I will set D2 as 1. But अगर odd parity है, तो I will set D2 as 0. Is this clear?
Yes, ma'am.
Okay. Then last was your carry flag. तो अगर entire result में carry generate हुआ है, that is from this bit, from the 15th bit to the 16th bit, if a carry is generated, I will set this D0 to 1. And if a carry is not generated, I will set this bit as 0. Is this understood? So we have seen carry, parity, auxiliary carry, sign and 0. We are remaining with ODIT. Now let us see that. What is overflow flag? A flag is set to 1 if the result of a signed operation is too large to fit in the number of bits available. Otherwise, it is set to 0. Overflow means what? How much is the size of my register? The size is of 16 bits. Barabar? Now, if my result has overflow, that means 17, 18, 19, 20 bits ka ho gaya. So what happens? This bit, O bit, D11 is set to 1. Why? Because overflow ho gaya hai from the in the result. So whenever this overflow has occurred in the result, at that time this bit will set to 1. And if there is no overflow, sab normal ho gaya, 16 bit addition has given me 16 bit as a result, then it will generate, or then this bit will be set to 0. Okay, that is what is overflow. So in any case, not due to the carry, but due to the system error, if a overflow has occurred, at that time this bit will be set. If अगर system के error के वजह से कुछ भी नहीं हुआ है, if I'm getting the result as 16 bits only, at that time this flag will be set to 0. That is what is overflow. Clear? Now next I have DINT. What is DINT? D is for direction, I is for interrupt, and T is for track. Okay. Now let me first tell you what is interrupt. What is interrupt? Anything that comes in the middle of execution is called as interrupt. Now, suppose I am teaching you in the lecture, and if I get a call, what is that call? That call is an interrupt. Now I will decide if that call is from my father, I may assume it that I can talk to him later and I can ignore. That means though the interrupt had come, but I had ignored the interrupt, considering that it was not important. But if a principal madam calls me, it is more important than the lecture. So I will make you on halt and I'll attend the call. Okay. Why? Because that interrupt from principal madam was of highest priority. So whenever an interrupt is means what? It is stopping the normal execution. What was our execution? We were into our lecture and I was explaining, you were understanding. So that was a normal execution. But a call came as an interrupt. So whenever an interrupt comes, I have to decide whether it is a higher priority or of low priority. So if an interrupt comes, I am going to set which flag. I will be setting this I flag, that is the interrupt flag. Okay. So execution के बीच में if I insert a pen drive, program execute हो रहा है और pen drive insert किया, तो does it show you the pop up? Yes, USB device, USB device is detected. Now it depends on you whether you want to click on that device and check the device or not. But an interrupt had occurred, yes or no? So at that time, this interrupt flag will be set to 1. And if the interrupt has not occurred, it will be set to 0. That is what is the I flag. Now, what is this trap? This trap, now as I told you, the interrupts are of priority. If my father calls, I consider it as a low priority and I am not going to attend. But if it is a principal, it is considered to be as a highest priority as the exams are going on. So I have to take that call. So like this trap is nothing but the interrupt with the highest priority. So you have different interrupt and every interrupt has a level, low priority, high priority, something like that. So it depends. If it is a higher priority, you have to compulsorily take that interrupt. But if it is low priority, you can ignore. So as I said, my father call was of low priority, so I ignored. But can I ignore the principal call? No, I have to compulsorily take that call. So if it is a higher priority, you have to compulsorily attend. So what is this T? T is nothing but the trap. It is an interrupt with the highest priority. So 808386 में जो interrupts है, trap is one of the interrupt and that interrupt is of highest priority. तो जब भी वो interrupt आया in between your execution, you have to compulsorily stop your execution and take that interrupt. But what is that interrupt talking about? It is talking about the debugging. That means there is some problem inside your computer. Therefore, that trap has been occurred. So whenever that trap occurs, the value of this T bit is set to 1. If at all there is no error occurred or there is no trap or there is no highest priority interrupt, then this bit will be set to 0. Is this understood what is trap and what is interrupt flag?
Yes, ma'am.
Okay.
Yes.
Then the last is the direction flag. What is this directional flag? This is used in the string operation. That means in a program, if you have a string operation, koi ye flag use hoga. If your program does not have any string operation, at that time this flag won't be set. Now what is happening? It will be either set to 1 or it will be set to 0. When it is set to 1, when the string will be accessed from higher memory address to lower memory address. That means come to your chat box. If I have a string like this, I have a string like this, A, B, C, D, E, F, G, H, I, K, J, K, L, M, N. Out of this, if I am going to extract or if I'm going to retract the string from A to N, that means from higher order to lower order, at that time, D will be set to 1. But when I try to access the string from N to A, that means from lower bits to higher bits, at that time, this flag will be set to 0. Okay. So agar operation program execute karte karte, if a program has taken A, B, C, D, E, F, G, H, I, my D will be set to 1. But if a program has taken N, M, L, K, J, H, G, F, C, D, S, something like this, then my flag will be set to 0. Okay. So that is a function of the directional flag. If it is set to 1, that means higher bits pehle access hue, fir lower bits access hue. If it is set to 0, means lower bits are accessed first and then the higher bits are accessed. Is this clear? Yes or no?
Yes,
So
ma'am.
in 80386, you have overflow, direction, interrupt, trap as extra status flags, whereas sign, 0, auxiliary, parity, carry are common with 8085. Is this understood? Yes or no?
Yes.
Yes, ma'am.
Yes.
Okay. So with this, we have completed all the registers of 80386. User visible also, condition and sorry, control and status also. If we come to the list again, user visible completed, control and status also completed. User visible may we had general, data, address and condition, and in control we had PCIR, MAR and MBR. Okay, so we have seen what are the different types of GPR. We have seen different types of control. We have seen different types of AR register also. And we also know now the size of the different registers. Is this clear?
Ma'am,
Yes.
ma'am, in the flag register,
Akash,
why is there empty space?
sorry.
Ma'am, in the flag register, why is there the empty space between the
Empty space means what?
digits?
Empty, empty space means those bits are not been identified and they will be always marked with 0. Because when you perform any ALU operation, what does a processor say? That when I perform any operation, ये चीजों के अलावा I do not encounter anything new. मुझे कैरी, पैरिटी, ऑक्सिलरी कैरी, साइन, ट्रैप, इंटरप्ट, ओवरफ्लो और डायरेक्शन, यही सब आता है. इसके अलावा मुझे और कुछ नहीं आता है. Therefore, the remaining bits are to be marked with 0. And since 80386 का flag register का size is 16 bits, therefore I have to make entire 16 bits का register. Whereas remaining bits I will be marked as 0.
Okay.
Understood?
Yes, ma'am.
Give me your attendance. Okay. So listen now, I had one more lecture today at 3 to 4. So we will be taking that lecture tomorrow as your maths lecture is not going to be conducted. Did you read the sir's message in your chat box?
Yes, ma'am.
तो आपका मैथ्स का लेक्चर कल नहीं होगा. So आज का जो CO का लेक्चर है that I will be taking tomorrow. Fine?
Okay, ma'am.
Okay. So we'll be meeting tomorrow. I will just tell you the time. Give me the attendance first. Faizan.
Present, ma'am.
Faizan.
Present,
Hamza.
ma'am.
Muzammil.
Present, ma'am.
Tahir present. Viraj.
Present, ma'am.
Om.
Present, ma'am.
Yash.
Present, ma'am.
Samarth.
Present, ma'am.
Devang. Devang. Reva.
Present, ma'am.
Soham.
Present, ma'am.
Jonathan.
Present, ma'am.
Sakshi present. Om.
Present, ma'am.
Mubul.
Present, ma'am.
Ashna. Dhruv.
Present, ma'am.
Sanika. Mayuri.
Present, ma'am.
Pritesh. Hiteshi.
Present, ma'am.
Aditya present. Prayag. Moez.
Present, ma'am.
Moez. Akash. Sonia.
Present, ma'am.
Disha. Aksh.
Present, ma'am.
Present, ma'am.
Sahil. Nidhi. Sahil.
Ma'am, in the
Pratham.
chat.
मैम साहिल ने चैट बॉक्स में लिखा हुआ प्रेजेंट.
हाँ ओके ओके. प्रथम श्लोक. देवांग. दृष्टि.
Present, ma'am.
पार्थ पटेल. पूजा.
Present, ma'am.
हाँ. कृष्णम. निर्मल.
Present, ma'am.
निर्मल. पृथु. हर्ष.
Present, ma'am.
Present, ma'am.
सॉरी. पृथु एंड हर्ष. कृषा.
Present, ma'am.
केनिथ. Kenneth, Vignesh,
Present, ma'am.
Jay, Nishit,
Present, ma'am.
Parth,
Present, ma'am.
Varshil,
Present, ma'am.
Shakira, Taha,
Present, ma'am.
Taha, Shah, Arjun,
Present, ma'am.
Prithvi,
Present, ma'am.
Keval, Sushant,
Present, ma'am.
Present, ma'am.
Dhruv,
Ma'am, present.
Present, ma'am.
Kush,
Present, ma'am.
Rudra,
Present.
Gayatri, Gargi, Gayatri, Gargi, both are absent. Kavya present. Nishant, Yash, Prem,
Present, ma'am.
Present, ma'am.
Sharad, Shrey,
Present.
Sharad, Tanmay, Naman, Tanmay, tomorrow maths lecture at what time?
1 second.
Ma'am, sir has sent a notice on the group that he won't be taking the lectures for a few days, like 2 to 3 days. So we don't exactly know if there is going to be any maths lecture tomorrow.
Arey, I
Ma'am,
Ma'am,
kind of.
tomorrow 11:30.
11:30 and 1.
11:30 and 1.
11:30 and 1.
Okay. I will keep the lecture in the morning 9 to 10 because at both the times second third year ka exam hai. 9 to 10, okay?
Okay, ma'am.
So we will be meeting tomorrow from 9 to 10. If in case there are any changes, I will put on the group. But if I do not message anything on the group, means you have to come tomorrow at 9 for the lecture. Okay?
And ma'am, try putting the today only because tomorrow morning.
हाँ compulsory है आज ही है. Just hold on, I'm getting calls. Hello. हाँ. कौन सा? Okay, we are meeting at 9 tomorrow. If I don't put the message by 5 today, that means it will be at 9 only. Clear? Dishank?
Yes, ma'am.
Okay,
Yes,
everybody else, we are meeting at 9 tomorrow. Bye.
बाय बोल के चले गए मैम फटाक से.
रिकॉर्डिंग चालू है.